Alrighty, so this is one of the legs of the Explorator churper species, which you can see consists of an M12 bolt as well as an M12 locking nut. So we have a normal M12 nut here, which provides additional sort of stability in locking, and then we have a locking nut on the other side, which makes sure that it doesn't drift once installed. So this ended up having a lot of problems. The nice thing is that these components are easily accessible as long as they're in a metric nation, and not too expensive. The length of these M12 bolts is limited, so it's harder to get them longer than maybe 200 millimeters or so, and they are relatively expensive when compared to shorter ones. Now, as you can see, once this is loosened up, then it can be adjusted by just hand twisting it, and we can move the height of the unit. Once we get the height that we want, then we can tighten this one in, and then we have to start the long process of tightening the other guy. Bottom of it. Because unfortunately this top guy can't really be tightened by hand. So just go through the manual process here and then tightening. And so on. So that's basically the configuration. And then you can see it actually wiggles a decent amount, which is also not very good. I think part of that is because of this locking, this T-nut that's used. So basically a hole's drilled out of MDF, T-nut is placed in, hammered in place, and then sort of epoxied and glued into place. So these were the initial legs. They made it quite apparent that there needed to be something that was a little bit quicker to adjust. Sorry, so we're going to go back to the original one here. And we wanted to make sure that it's also something that was a little bit more sturdy. So now moving on to the next species, we have a Explorator pecker, which is modeled after a woodpecker. And we have a different leg design, so we have these 12 millimeter stainless steel rods. It's held into place with this sort of coupling mechanism, which is also made out of a stainless steel, I believe, or titanium. And what it does is it basically clamps it together according to how far in the screw is screwed. So I can loosen it up to free the leg. Once the leg is free, then it can very easily just kind of slide up and down to whatever height you want. Once I get it to the height that I desire, I can kind of hold it in place with one hand. With the other hand, I can tighten this using a hex wrench. Alright, cool. Got that tightened. I'll give it one more to make sure it's a little extra sturdy. And then that is not going anywhere. Now, I chose to use this nice black oxide finish on these fasteners here because over time they develop these beautiful rusting colors, which makes it sort of apparent the vulnerability that these devices have. This design is quite a bit simpler than the previous one. And then on the opposite side, if we flip over the device, we flipped it over, you can see it's just bolted onto the bottom there. There's just simply a hole in the MDF where the leg comes out of. Now, to avoid being in a circumstance where the tip is always going to be at the end of the rod, which has a tendency to sink into different locations, specifically sand. Designed a few different feet they can fit onto the bottom. So this is one of the feet, which is fastened using that screw, and then it actually has a little bit of a gripping pattern on the bottom. So this one's good for asphalt, this is good for grass. It's just kind of the general purpose leg. So this is another leg, this much thinner, just meant to sort of cushion around the not necessarily sharp, but sharp edged feet. So the leg configuration did prove a lot more successful for pecker than it was for churper. The legs were much easier to adjust. Overall, the configuration was lighter. The legs could be removed easily during transport, and actually they provide more sturdy. So in pretty much every metric, it was a vast improvement. So for the next species, which needed to be made in a very short period of time, what I ended up doing is actually reverse engineering those couplers, those brackets in the last one, and 3D printing it out of PETG, which is relatively sturdy plastic that's weather resistant I could rely on. And then that again uses the same mechanism of a screw that's screwed in order to tighten and then keep the bolts into place. And then once it is loosened, then the bolts can freely slide. And there we go, the bolts can freely slide back and forth once it's loosened, and once it's tightened, again using a hex wrench, and a few turns here, and then this one actually, yeah, then it becomes firm and does not move back and forth. Alright, cool. To give the units additional stability, a bracket is added on the top and the bottom of the body, and then held together using a single bolt and then a locking nut. And washers on each side, so they're sandwiched together. They both have this clamping mechanism. I've so far left the bottom ones just sort of open, so they're just kind of there to provide structural guidance for the pull that's going through, and then the tightening is just occurring on the top one. And this also makes it so that I can tighten them quicker. And then this actually does provide a good amount of additional stability. It's really hard for me to wiggle this leg, where it is possible for me to wiggle the leg in the previous version. Additionally, then I don't have to actually buy the brackets. I'm using the plastic. I can 3D print it myself. They end up being cheaper, and then, you know, quicker. I can 3D print them, and I was able to build this in just a few days using a 3D printer and what I had lying around. And of course, you know, kind of lessons learned from the framework.